The stratosphere is a very interesting place, and if you think about where weather in the stratosphere actually comes from, the answer will be quite surprising, because weather in the stratosphere originates from the surface of the ocean. Depending on the evaporation that occurs there in the atmosphere, various stratospheric vortices are formed, which are influenced by factors such as temperature and pressure. They have certain cycles of existence and play a crucial role in atmospheric dynamics. For example, in the equatorial region, which is roughly between approximately -30 and +30 degrees latitude, there exists what is called the quasi-biennial oscillation, such as in the range of... This phenomenon provides a near-zero wind speed at a certain height. During this quasi-biennial oscillation, the height at which the wind speed is zero moves from the bottom to the top, reconfigures from the bottom to the top, and this goes on indefinitely. Accordingly, below this height, the wind blows in one direction, while above this height, the wind blows in the opposite direction. This allows us, by changing the height, to adjust our direction to the west or east, which is essential for navigation and understanding atmospheric dynamics. In the northern hemisphere where we live, a cycle of the polar vortex occurs every year, significantly influencing our weather patterns and climate conditions. So, somewhere from October to April, throughout its thickness, from the ground up to 30-40 kilometers, like when water swirls in a bathtub, a vortex starts to form. This vortex is quite powerful, with speeds in this vortex reaching an extremely high 300 km/h or even more. Incredibly fast. This occurs at heights of 20 kilometers and above. Sometimes this vortex breaks apart into several pieces, into 2, 3, or even 4 parts, and sometimes it collapses back together. This has a significant impact on the weather. When it's -40 in Moscow during winter, it means that the polar vortex has broken apart, and the weather, with winds from the Arctic, brings cold air from the Arctic to more southern latitudes. In the summer, during the summer season, we carefully observe an extremely stable speed field at these high altitudes above 15 kilometers, with speeds of several tens of kilometers per hour, not more, while near the pole the speeds are almost zero, just a few kilometers per hour in the atmosphere. And there you can practically hover for any amount of time. It's a very predictable trajectory, essentially moving along the latitude.
And at that moment, on the other side of the planet, at the South Pole, the same vortex appears that we had in the Northern Hemisphere. And when we have a vortex, the weather there is quite calm.
Yeah, soon Fyodor will take my job with such knowledge of the stratosphere.
Come on, don't talk about me. Let's put it another way. It turns out that not only the ocean, but also the tilt of the axis affects which way we plan to glide.
The cycles of summer and winter also have a significant influence on the stratosphere in various ways. Moreover, Tibet has a huge influence on the stratosphere because large obstacles that air masses encounter cause them to spread out significantly in waves upward, which in turn affects whether the polar vortex breaks apart into several pieces, or conversely, whether it subsequently recovers and potentially influences other atmospheric conditions and other related factors. So everything is very closely interconnected. The entire atmosphere, in all its thickness, interacts very strongly both with each other and with space and the Earth.
And with the laws of physics, for example, Coriolis, it's very interesting. And the stratosphere forms a very thin layer. It's practically an imperceptible thing, yet such high speeds are realized there. You can observe similar vortices on a soap bubble. When you blow it up, you can see that they are a bit chaotic. If a soap bubble were stable enough and entered some kind of cyclical system, you would definitely see similar magic, for sure.
In fact, on one hand, it actually appears to be unstable because such speeds are constantly and consistently carrying something away. There's a vortex here, some circulation there, a biennial cycle here, and a yearly cycle there. But all of this is so truly incredibly and exquisitely beautiful and so meticulously accurate that these patterns can be used in a way that is effective to solve practical problems. For example, the polar vortex, which is essentially the primary driving force for the stratospheric balloon, actually shapes its orbit above the Earth in the atmosphere, such as we can launch several such devices. We can send out a dozen devices with a certain distance between them along the vortex, and they will orbit at roughly the same latitude like satellites. This allows for communication, retransmission, monitoring, imaging, and scientific research, such as advanced. For example, in the Arctic zone, we can launch stratospheric balloons with telescopes, and because the influence of the atmosphere is very minimal at such high altitudes, we will be able to see space almost without distortion, and this is tens to hundreds of times cheaper than launching the same telescope into orbit. Moreover, a telescope on a stratospheric balloon can definitely be serviced, while a telescope in orbit is practically impossible to service. This type of technology definitely has potential. In principle, undoubtedly, within many strategic processes, both in Russia and abroad, the stratosphere is referred to as a reserve layer, a buffer layer between space and the atmosphere. If something goes wrong with space or with the lower atmosphere, the stratosphere serves as an alternative for solving many problems in various scenarios and challenges, both for space vehicles and for aviation, in the field of technological advancements and innovations.
It seems like many people are really striving for that and have indeed been making these probes their whole lives. Soon, it will probably be a century since people have been flying up into the stratosphere, but for some reason we don't see a strong presence of this stratospheric technology. Google tried, but where did it go? There are opinions and theories, share yours.
We spoke with the systems engineers of the Loon project, which is a Google initiative that also dealt with communication tasks, providing connectivity in various regions. They, as many are unaware, primarily focused on quasi-biennial oscillations around the equator, meaning they didn't fly at latitudes north or south of the 40th parallel in the southern and northern hemispheres. They intentionally and very carefully avoided those specific latitudes because there are intricate and complex coordination challenges with the country of Russia, which occupies a substantial and significant part in the vast and expansive northern hemisphere, especially when considering the Arctic Ocean. And there, the phenomenon known as the stratospheric vortex has greater consistency. Different physical phenomena and various patterns, such as wind patterns, temperature variations, and atmospheric pressure changes, are used to maintain the area or support the stability of the stratospheric balloon's trajectory in tropical and northern latitudes. These factors are crucial to effectively manage and control the flight path, ensuring the balloon remains stable and on course. The northern latitudes are more advantageous in terms of ensuring flight stability. According to our detailed calculations, as part of an extensive and ongoing initiative research project in this specialized field, a group of 72 highly advanced and strategically positioned devices in our northern latitudes provides comprehensive coverage for an impressive 80% of the entire northern latitude region. We specifically calculated for the critical and economically significant northern sea route, but at the same time, this extensive coverage spans from the latitude of Murmansk to the latitude of St. Petersburg, and potentially even reaching as far as Moscow, which is a major metropolitan area. So that's a considerable number of devices that can fly for months or even over a year in total.
And Google, for its part, chose equatorial regions. If the northern hemisphere is more or less covered by the internet, like Europe, North America, and Canada, they were planning to provide internet in the equatorial countries of Africa and South America.
This is a technical question. I addressed the issue regarding the patterns, the task of flying a stratospheric balloon in northern latitudes as well as in tropical latitudes. These are different tasks, completely different tasks, and it's easier in the north, yes, but there are also, of course, organizational issues in this case. There is a widespread opinion that Google makes money from every internet user. Essentially speaking, it doesn't matter to them where that user comes from. By developing the Loon project, they aim to increase the number of internet users. At the same time, the Starlink project began to be developed and expanded, which was no longer financed entirely from Google's budget, but at the same time offered the exact same coverage in terms of the Loon stratospheric balloons, and because of this they saw Loon as simply an unprofitable investment. Why spend money yourself if the same task will be solved by another player? This opinion is also valid, but it is a bit...
It was indeed a very logical closure of the program. Putting all our factors together, it is clear why it makes sense for us to do this. First of all, no one is giving us Starlink. Secondly, even if they do, it's unlikely that our people would choose it to ensure technological sovereignty. In any case, indeed, many countries are definitely planning their own systems, and ours is certainly called Sphere. As Arkady rightly pointed out, launching something into space is much more expensive. It will be unserviceable, and it requires long-term investments. We can efficiently and swiftly master the stratosphere in a relatively short period of time, and I hope we will demonstrate that